Beta plus decay. These are called positrons. Now these babies are great. They're the antimatter particle of a of an electron. They're basically a positive electron, and it happens when the nucleus has too many protons and is unstable. So in this case here, unlike the neutron which split before, the proton will actually, I guess it doesn't split, it just changes its internal contents, but it changes so that it becomes a neutron. This here, note, this is look very similar to an electron, but it's not, because you note that the charge here is not -1, but rather it's just 1. It's +1. That's a positron. And this is a neutrino. Neutrino is different because it doesn't have the lid on the basket. Lid on the basket is antineutrino, and this is a neutrino. Now, if you're going to come along and ask me, what is the difference between a antineutrino and a neutrino? Well, a neutrino is released when a positron is released, and an antineutrino is released when a electron is released. And that's it. That's the limit of my understanding. I probably need to look into it a bit further. So proton becomes neutron, positron, and neutrino. Charge is conserved again because you've got +1 here for your proton, and you've got +1 here for your positron. So its charge is +1 over here, and it's also +1 over here because the neutrino and the neutron have no charge overall. And again, the nuclear number is conserved, whereby the proton weighs 1 and the neutron weighs 1, and all of this other stuff here is massless, even though electrons weigh 9.11 by 10 to the -31 kilos. Now, there's more than just a positron. Beta plus decays also have the discrete range of energies too, and some emit gamma radiation at discrete energies. This is the thing, it tells you again that the daughter nucleus is at a specific energy level, because if it had random energy levels, then it would release random gamma rays, but they don't. Out comes the positron in discrete speeds, and out comes the gamma rays of specific wavelengths, which confirm a set of very specific energy levels for nucleuses. Now, write an equation to represent the beta plus decay for nitrogen 13.